In the previous two examples, we both calculated the deflection at the free end of the cantilever part. So the example 3 will calculate the deflection of the beam at the middle of the simply supported part. In this example, the figure is shown here. So the A, B values have been given, and the distributed load W is given. P at the free end is 40 kilonewton, and the EI has been given as 200,000 kilonewton square meter. Okay, and as we analyzed in the theoretical parts, this one we still need to split it in. So we can split it in the same way as we did for example 2. Right? It's if you can go back to example 2 to see how did we split it into 3 beams. But the first one, the beam 1, is not important since we analyzed that in the theory part. The beam 1 can be ignored since all of the effect on the simply supported part can be concentrated to this bending moment M. Right? So we only need 2 beams. Right? If you can solve the simply supported beam loaded by the distributed load W, and the simply supported beam loaded by the M at the right end, then add them together, you will get the deflection at the mid-span of the simply supported part. Okay, so we're just splitting. Actually, we split it into 3 beams, but the beam 1 had been ignored, so we have only 2 beams left, and we name this beam 1 and beam 2. Okay, so let's look at the beam 1 first. Okay, so for the beam 1, it's a simply supported beam subjected to a uniformly distributed load. So in the table, we can find this is this one, right, this beam. So to solve its deflection at the mid-span, we can either use equation 11 or equation 12 with L equals L over 2 at the half span of the beam. Right? So here we can use either equation 11 or equation 12, where the x equals L over 2. In this case, A over 2. Right? Okay, here's this L in this case equals A, that is 6 meter. And the W is here, 17 kilonewton per meter. Okay, we are not necessary to convert these numbers into millimeter, Newton, MPa, etc. Since, as we just said for the example 1, if you can keep the units consistent, which is so you don't have to convert them. Okay, we just use meter and kilonewton here in this case, since the EI used this unit system, kilonewton square meter. So we can keep meter and kilonewton everywhere. So in this case, the delta 1, if we use equation 11, the delta 1 can be calculated as negative 5 W L to the 4th over 384 EI. Right, that is negative 5 by 17 by 6 to the 4th over 384 by 200,000. And here you can get negative 0.001434 meter. And this is a downward deflection. Right. So then let's look at beam 2. Beam 2 is here. Right. The beam 2 is a simply supported beam subjected to a bending moment at the right end. Okay. And again, it's the equation of this is the case. Right. But in this table, this bending moment is added to the left end. Right. Then we can use equation 9. So we can use equation 9 to solve this problem. Right. So here the equation for equation 9, we need to determine the m first. The m equals pb. P is 40 and b is 2, right? So you get 80 kilonewton meter. Again, strictly speaking, this should be a negative bending moment, but we just use its magnitude. The delta 2 is just negative. Okay, so here this is equation 9, right? So delta 2 can be calculated as negative mx over 6LEI by 2L square minus 3LX plus x square. So at the middle point, at the middle span, this x equals 3 meter, right? So then this one can be calculated as negative it's negative 80 by 3, x equals 3 meter over 6 by 6 by 200,000. 2 times 6 square minus 3 by 6 by 3 plus 3 square. So the results would be 0.0009 meter. Right here, again, the sign here is not that important, since you just need to understand what is here. When you add this bending moment at the right end, it will be curled up, so this deflection will be upward. So you just need to use upward sign to denote the deflection. Then the overall deflection at the middle span, the delta, will be delta 1 plus delta 2. Okay, the delta 1 is 0.001434, and delta 2 is 0.0009. And the delta 1 is downward, so we denote it as negative, and the delta 2 is upward, we use a plus, is a positive sign for it. So here you will get negative 0.000534. meter, and this is a downward deflection, or this is a negative 0.530. Okay, 0.534 millimeter, but downward deflection. That's it.